All right, we start from here. I was discussing about the examples of scenarios with one-way ANOVA application because if your data is normal and equality of variance is assumed, you may likely to use one-way ANOVA for more than two good comparisons. So, what are the example? How would we understand that this scenario requires the testing of one-way ANOVA? So, there are some certain examples that I would recommend that you need to know that how will we decide that these scenario require the one-way ANOVA application. So first is pharmaceutical company. A pharmaceutical company is testing the effectiveness of three different pain relievers. Just a minute. Yes. A pharmaceutical company is testing the effectiveness of three different pain relievers, A, B, and C, for post-operative patients. The pain levels of patients are measured after a specific time interval. One-way ANOVA can be used to determine if there are significant differences in mean pain levels among the three different pain relievers. So this is a situation where more than two categories of the data in terms of pain relievers uh, can be compared with the specific time or the time to relieve from the pain. In the same way, a school district is evaluating the impact of three teaching methods. Uh, do not confuse the word three with multi-group analysis. I am just exemplifying it. You may use more than three groups in case of multi-group analysis. So a school district is evaluating the impact of three teaching methods: traditional, online, and blended. Blended basically is the combination of traditional and online. So a school district is evaluating the impact of three teaching methods, traditional, online, and blended, on student performance in a standardized test. One-way ANOVA can be employed to assess if there are significant differences in mean test scores among the three teaching methods. So you may analyze the three different teaching methodology with their student performance. How would they score in a particular test? How they score in their exams, and how they would score in their quiz, etc. So how which one of the teaching method is more effective as compared to other? So psychologists are studying the effect of various therapy approaches like cognitive behavioral therapy, psychodynamic therapy, and humanistic therapy on reducing symptoms of depression. So symptoms of depression might be your continuous variable, while these three types of therapies would be your categorical variable. So one-way ANOVA can be used to investigate if there are significant differences in mean depression scores among the three therapy approaches. One situation might be a manufacturing plant is testing the impact of different production methods like ABC on quality of product. So quality of product might be your continuous variable, while three different production method like ABC would be your categorical variable. So in this way, we can assess the ANOVA. And the last but not the least, the market researcher is examining the effectiveness of three different advertising strategies like television, online, and print in promoting a new product. One-way ANOVA can be used to assess if there is significant difference in the mean consumer response score. So consumer response score would be your continuous variable, while three types of advertising strategy would be your categorical variable. So actually you are comparing the continuous variable with your categorical variable in this scenario. So here start your example number one. This is a hypothetical data file that concerns the popularity of a TV channel. Using a prototype, the marketing team has collected focus group data. One of the question of interest is to see the difference in popularity of the TV channel in different age group. Basically, the age groups may be they may be three, they may be four, they may be five. So the researcher would like to know that the popularity of TV channel may be different in different age groups. So example one is related with this. I have shared with you the example one data set. You may open it. I have shared the file. You may open it, example one data set, and how would it be applied? You simply need to go, you just need to open it, because I do not have attached the screenshot of this process, so I will verbally and orally explain the process in front of you. So you need to see this process carefully. What is the SPSS process for applying this procedure? First you need to set your hypothesis. What would be your hypothesis? Step one: there is no statistically significant difference in popularity of TV channel in different age groups. It means this is your null hypothesis, which is telling you that you are not considering a significant difference in the popularity of TV channels in different age groups, while your alternative hypothesis would be there is a statistically significant difference in popularity of TV channel in different age groups. So this is how you can develop your statistical hypothesis like H naught. All all groups are equal, all age groups are equal, or H1, at least one group is significantly different. Or you can say that the at least one group is not equal with others. So this is how you can prepare the hypothesis of a multi-group analysis. So how we can do it? First, you need to understand the SPSS process. You need to check the normality of the data. If the data is normal, use one-way ANOVA. Check the assumption of equality of variance also. So you need to verify three things. First thing, normality. Second thing, if the data is normal, you need to use one-way ANOVA on priority basis, and then you need to verify the equality of variance. So how you can do it? You can go to the analyze, then you select the non-parametric test, then you choose the legacy dialog box, then one sample KS, and it will show you this screen. You need to put your continuous variable, not categorical variable, only continuous variable. You need to put your continuous variable in test variable list, and you need to click OK, and you will see a result like this. Asymptotic sig value is greater than 0.05, so we can say that our data is normal. And how would we interpret this? Since the level of significance, which is asymptotic sig value, two tail is equal to 0.092, which is greater than 0.05, therefore the normality assumption is fulfilled. That is the first requirement we have met. The second is appropriate test. As the data is normal, therefore one-way ANOVA will be used for testing the hypothesis. However, we additionally need to check for equality of variance. That is the important thing that we need to consider. So how we can do it? Go to analyze button, compare means, check, select one-way ANOVA, and here you will find you need to put your continuous variable in dependent list, and you need to put your categorical variable having different categories in factor list. And what you will do, you will select options. There is a box with the name, there is a button of option. You will click on that button, and you will find a table like this, from where you will select or you will check the descriptive box and homogeneity of variance test box, and you will select continue button, and then after it you need to select the OK button, and then you will find a table like this, the output table. The most important thing that you need to find over here, there are three tables. And how do we interpret? The first table is showing the mean age value of television popularity between different age groups, and you can see that uh, most of the people from the age category of 39 to 45, uh, uh, most of the people are giving popularity to the TV channel in the age category of 39 to 45. And Is these differences between different age groups regarding the popularity of TV program is significant or not? But before deciding it, you need to see the second table. If you can see the second table, uh, you would find out that when the sig value when the sig value of Levine test is greater than 0.05, it means equal variance is assumed here. So, as you can see, there is a table, Levine test, the table number 2. It is showing a sig value which is greater than 0.05. So, when sig value of Levine test is greater than 0.05, it means equal variance is assumed here. We further need post hoc analysis. So we need to analyze some post hoc analysis that I will let you know. And the third thing, we need to see the ANOVA table and the sig value more specifically. So this table will let you know whether the mean difference between different categories are significantly different at overall or not, but not individual. In overall, there is a significance difference between groups, but we cannot confirm the significance difference between each independent group here. So in order to confirm the significance difference between each independent group, from, for example, from group 1 to 2, from group 1 to 3, from group 1 to group 4, group 1 to group 5, and so on. So if we would like to analyze the group by group significance difference, we need to go towards the post hoc analysis. While this sig value is indicating that overall there is a significance difference between all the groups, not two individuals groups. So we need to check for post hoc analysis further. So how can we apply the post hoc analysis? Just go to analyze, select compare means, then go to one way ANOVA, and you will find out the table like this. You need to put your dependent variable list in with your continuous variable, your dependent variable, and you need to put your categorical variable in factor list. And here is a button, post hoc. We need to analyze post hoc now. Why we are using post hoc? I would like to know the reason. The reason is when your homogeneity of variances is confirmed. When it is confirmed, or when the assumption fulfill for homogeneity of variance like this, you need a post hoc analysis. But if your homogeneity of variance is not confirmed, you need to put another procedure. So I will let you know how this is done. So you need to click on post hoc button. So when you click on it, you would see two parts of this window. The first one is equal variance assumed. The second one is equal variance not assumed. In our case, equal variance was assumed because if you see in the previous slides, you can see that the sig value of Levine test is greater than 0.05. It means equal variance is assumed here. So in our data set, equal variance was assumed. So we need to check the options of first window. So whenever your equal variance were assumed, you need to click LST or TACI. These two tests are very important and very prominent. Majority of the researcher and data analysis use TACI measure, and some of the researcher use LST, and some of the researcher use both measure. Sometimes they give the similar results, and sometimes their results are different. So whenever their results are different, I would personally prefer the TACI, and majority of the researcher use Turkey if the results of LSD and Turkey are different. So when your variances are assumed to be equal, use LSD or Turkey. And when your variances are not assumed to be equal, like if our equality of variance assumption is not fulfilled, then you need to use the second option, that is Dunnett's T3 option. So you need to click OK button, and you need to go next, and you will see a window like this. and you will see individual differences. Uh, in 18 to 24 years window bracket, there is no significant difference of 18 to 24 with any age group. You will not find another any significance difference between the 25 to 31 age category and other. But in the age category 32 to 38, you will find a significant difference or comparison with 53 to 59. How would you find out the significance difference? There is a steric. There is a steric on mean difference value. So whenever you find a steric on the mean difference value, it means this value is significantly different, and you will need to see the category of that row and along with their parent category. So we can interpret over here that there is a significant mean difference between the age group 32 to 38 years and 53 to 59 years. In the same way, if you come right side, you will see that there are some more values with the steric button or with the steric sign, and you can see within the bracket 46 to 50 years is significantly different from 39 to 45 years age category, and 53 to 59 years age category is significantly different from 39 to 45 year age category. In the same way, 46 to 52 years age category is significantly different from 39 to 45 years age category. So in the same way, you can interpret others. This is basically the Tucky HSD. While there is some other uh, interpretation of LSD, and you can see it is showing some significant figure in 39 to 45 age category in comparison to 18 to 24 age category. So these results are different from the previous one. So whenever the results are different from the previous one, or if the Tucky HSD and LSD are giving different results, so always prefer the Tucky results, because most of the researcher use this technique to analyze the individual differences. So here in LSD, the results are different because it is giving more and more results about the difference of different variables. So this is the analysis procedure. How would you interpret the sample T stat in APS style? So in the same way that I have done previously. So before doing the example 2 drill, I would personally like to use the data set. This is the data set I have used here. Just I need to know the normality of the data. Just go to this procedure, use your continuous variable, click OK. You will see asymptotic sig value is greater than 0.05. It means your data is normal. Just go to analyze, compare mean, and one way ANOVA. Select it, put your continuous variable here, your age group variable in factors, and click option. You need to choose descriptive, you need to choose homogeneity of variance test, and then you need to click continue, click OK, and you will find a table like this. First, you need to see the test of homogeneity of variance. If the test of homogeneity of variance, like Levine test statistic, is greater than 0.05, it means you need to go to post hoc analysis for individual differences. Here you can see the sig value of ANOVA is less than 0.05. It means the differences of the mean between all the groups overall, all the groups is significantly different, but it will not indicate the individual differences between the groups. So we need to analyze the data using post hoc analysis. So for the purpose of doing this, go to the one way ANOVA and click on post hoc. So as our equality of variance is confirmed. So we need to click LSD and touchy, and we need to click continue. We need to click OK, and you will see a table like this. And it will take a lot of time to verify the individual differences or interpret the individual differences. So you need to identify which variables are showing, or which mean differences are showing of which category with a steric signs. So identify only those mean differences values with which have the steric signs with them. So interpret them, and you will complete this process. So your next task is to complete the example 2 drill. In the example data set, the variable math, I will show you the complete string, and I will give you 5 minutes to complete this task. In the sample dataset, the variable math and English are the score the respondent obtained during their exams, and smoking is an indicator about whether or not respondent smoke. If a person is non-smoker, it will be indicated by 0. If a person is past smoker, it will be indicated by 1. And if a person is current smoker, it will be indicated by 2. Can we conclude that if there is a statistically significant difference of average marks of math and English with respect to smoking status? So please analyze the example number 2 that I have given to you. You have 5 minutes to complete it. And if you have any question, you may ask the recording. All right. After drill 2, you may consider another example. You may also consider drill 3 or example 3 as a drill that you may try after the training session is completed. I would just read the statement. Let us assume that you are comparing the test score of 3 different teaching methods: traditional, online, and blended. So, is there any significant difference between the average test score of these groups of different teaching methods? So, you would basically try this data set as another example of understanding this case or this process. So, the second case is normal data with unequal variance. So, what will we do if the analysis procedure indicates that our data is unequal, our data is normal but showing unequal variance? So what will we do when your data fulfills the normality assumptions, uh, but uh, equal variance assumption is violated? The test appropriate for multi-group mean comparison of such data would be Welch ANOVA. So what options do we have when we have normality assumption is fulfilled, but equality of variance assumption is not fulfilled? We need to use Welch-ANOVA test. So what is Welch-ANOVA? Welch-ANOVA is used to compare more than two groups on the basis of their average without assuming equality of variance. So what is Welch-ANOVA? The further detail of Welch-ANOVA indicate uh, Welch ANOVA or analysis of variance is a modified version of the traditional one-way ANOVA that is designed to be robust when the assumption of equal variances among groups is violated. The standard one-way ANOVA assumes homogeneity of variances, meaning that the variances of the groups being compared are roughly equal. However, if this assumption is not met, the result of the traditional ANOVA may be unreliable. So Welch-ANOVA introduced by statistician B.L. Welch. Uh, Basically, this test is related with his name, which is particularly useful when sample variances are unequal. It adjusts the degrees of freedom and the test statistics to account for this inequality, providing more accurate test in such situation. So, what are the assumptions of Welch-ANOVA? Welch ANOVA, like traditional ANOVA, has certain assumptions that should be considered for reliable results. While it is more robust to violation of assumptions of equal variances compared to traditional ANOVA, it still has some underlying assumptions. Here are the key assumptions of Welch ANOVA. What are the assumptions? First, is data type DV must be continuous and IV must be categorical. Independence, there must be independence between or within each group. Each value of one group must be independent from other groups. uh, Normality of the data is normality assumption is fulfilled. However, equality of variance may not be fulfilled, like I have previously said. So how can we consider the data? We need to see the example number 4. You are provided with the data of 80 individuals on their test score by attending training on three different methods. Is there a significant difference between each method? And to analyze example number 4 orally, because I didn't have attached a screenshot over here. So we have the example 4 example 4 in our data, and here it comes. We need to analyze the data of 80 individuals on their test score by attending training on three different methods. So 80 individuals were provided three different training methods, and you would like to analyze how they performed in their test. All right. You can see the data set like this. You have test scores, and you have different types of groups. Like one of the groups was provided training on method one, the one of the group was provided training on method two, and one of the group was provided the training on method three. So there are three types of groups which were provided different types of training, and these three different groups were compared with their test scores, how they have performed with the test score. So this is basically your continuous variable. Your test score is your continuous variable. You need to check the normality first. You go to analyze button, you go to non-parametric test, you select one sample ks, and you need to select the test score as a test variable list. You click ok button, and you will see the results like this. So here it shows that the data is not normal, but remember one thing: if your number of observations are greater than 30, because when we are dealing with multi-group analysis, when we are dealing with multi-group analysis, we may have more than 30 observations. So here are 80 observations. So in case if there are more than 30 observations, you don't need to check the normality assumptions. We may consider it normal. In case if you have less than 30 observations, you need to check the normality using the usual procedure. So how can you analyze the data? You go to the next procedure. You go to compare means. You go to the independent sample t test, because as the number of observation are more than 30, so we consider it as a normal. So you need to put your test score on the test variable list. You need to put your groups in your grouping variable. Then you need to define groups. So here we need to see our the values of our group. So how can we check them? We need to go to our data set. First, we need to look at our data set. So there are three values: 1, 2, and 3. The minimum value is 1 and the maximum value is 3. So we need to put it over here. We go to the compare mean, we go to the one way ANOVA. We need to put our continuous variable independent list. We need to put our group variable in factor list. And yes, we go to the options. We need to select descriptive and homogeneity of variance over here. You need not to select the Welch test option at this point in time. You just need to click continue button. You need to click OK, and you will see a result like this. Here you can see that in the second table, the Levine statistic value, the sig value are less than 0.05. It means normality assumption is fulfilled, but homogeneity of variance is not confirmed over here. It means equality of variance is violated. So you can see that you need to go to the post hoc and you need to select the relevant option for this. In the meantime, you can see the mean values of method 1, method 2, and method 3. All right, guys, there was an interruption. There was an interruption from the internet, and I have started again sharing my screen. I was discussing this output stream, what the values are telling us. Uh, I was letting you know the test of homogeneity of variance. The sig values are less than 0.05, and these values are letting you know that you need to unable to hear you. Are you hearing me now? Please let me know. Maybe previously the network connection was interrupted, but please let me know. Can you, all people can hear me?
Yes, sir, we can hear you.
All right, all right. Well, I was letting you know that first you need to check the homogeneity of variance table, and this table is indicating a value less than 0.05. It means the homogeneity of variances or equality of variance is violated. That was our second case. The second thing that you need to check is ANOVA table. ANOVA table sig value is showing a value less than 0.05. It means overall overall the three groups are different, but we need to check whether the method 1 is different from method 2, method 1 is different from method 3, method 2 is different from method 3. How can we assess the individual group differences? In the overall, these groups are different from each other, significantly different, but individually I need to verify. So how can we verify? I will go to the procedure again. I will go to analyze. I will go to compare means. I will select one way ANOVA, and then I will go to the post hoc button. You need to click it, and as we all know that our data is not equally, no equal variances were assumed because the violation of our assumption was violated. So we need not to check LSD and Tucky. LSD and Tucky would be checked when equal variance assumptions was confirmed or fulfilled. But in our case, equal variance assumption is not fulfilled for it. So most of the researcher use the second option, that is Donet's T3. You need to select it and you need to click continue. And then you need to click OK button. And you will find a table like this. This is basically individual comparison table. Here you can see that method 2 is significantly different from method 1. Method 3 is significantly different from method 1. In the same way, method 2 is significantly different from method 1. Method 3 is significantly different from method 2. In the same way, method 3 is significantly different from method 1. Method 3 is significantly different from method 2. So you are seeing the spheric signs with all of these mean differences. So here we can say that individuals as well as overall there is a significance difference between the values. So here this is how you can interpret the values. So next we have example 5 as a drill. You have a 5 minutes to complete this drill. uh, you have a data set of, for example, number 5. So you have 5 minutes to complete it. I will read the statement of this questionnaire, and we are going towards the last part. After it, uh, there is only one data set that I need to elaborate. So complete it fast. A sales manager evaluates two new training